Good morning and welcome to day 3 of Python Astronomy 2018. We've got a 1-hour block of talks this morning, then some more food and coffee, and then second half block of talks. And our first speaker this morning is talking about a topic that I think is important to all of us, regardless of our specific disciplines. Arfon Smith will be talking about how to get career credit for software.
Thanks. And can everybody hear me okay? Is that coming across all right? Great. All right. Good morning, everybody. Thanks for the opportunity to speak here. This is a great audience to talk about these topics with. So just a little bit about me. I'm a sort of lapsed academic. I have a PhD in astrochemistry. I stopped trying to do research in astronomy and astrophysics in 2006, straight at the end of my PhD, and have since then sort of had various positions writing software in various research domains. And so these days I find myself at Space Telescope, running a new mission office there called the Data Science Mission Office, which includes basically working out what we should do in terms of building data analysis tools across all missions, such as Hubble, JWST, and in the future things like doublea first, hopefully. And so what I do with my research time, which is about 20% of my time, is I think about how to improve scholarly ecosystems to, in particular, improve the sort of career prospects of people writing research software, so maybe people like in this room. So I wanted to give that background, so don't ask me anything about Python or astronomy, because I don't know very much about either, but I care a lot about them both. Okay, so I wanted to talk first about the fact that one thing we sort of know, I think instinctively, especially this audience will know, software is kind of pretty important to our work. And I think when you sort of wanting to advocate for something you think that matters, it's always good to be able to point to research that backs up your kind of feeling. And it turns out that people have conducted relatively large surveys of scientists. This one from back in 2009 was of about 2,000 scientists. And one of the questions they asked was, how important is software to your research? And upwards of 90% of people report that software is either important or very important to their work. I think that's probably obvious, but it's good to have something to point to. And I think what's kind of worrying me about the kind of current trend in the sciences is that software is only going to become more important over time. And I think this is in large part due to instruments like this, the LSST, so very large facilities producing a lot of software where lots of people are going to be working on those same similar data products, or maybe it's next generation infrared missions. This is the latest picture I could find of what W first will probably look like. Or maybe it's because your research field is really invested in simulations. Whatever it is, software is a core part of both the generation of data and the analyses. And I think Victoria Stodden, who some of you might know that name, she's written a lot about reproducibility and the gap in sort of publishing cycle, which is sort of, there's now deep intellectual contributions captured in software. And if all you're doing is writing a paper and talking about your results, and you're not supplying sort of the full materials of your work, this is a problem. And she frames this as a sort of reproducibility problem. But I think this is a nice quote. And here's another one from somebody who's obviously very familiar to this audience. We also have, just if you don't care about reproducibility, if you just care about the strength of our universities and the people that stay and have successful careers, we have this challenge that all the tools that we're working on here and all the skills that you are all acquiring and honing are very, very applicable in settings outside of the academy. So this is something to be concerned about, of course. And Phil Bourne, who actually is no longer Director of Data Science at the NIH, but don't let that distract you from, I think, his sage words here, that we need to find a way to legitimize software as a form of scholarship. So I realized I started talking about this, certainly in front of astronomers, about 3 or 4 years ago. And it used to be true that there were, there weren't very many things. There weren't a collection of obvious places to go and publish software and to maybe get career credit. But it turns out that a lot of that is changing, certainly in astronomy and astrophysics. So I'll talk a little bit about that in the end. But certainly in many disciplines today, it's still not clear if you're writing research software what you do with that, how you get career credit for that. And some of those challenges are ecosystem problems, and some of them are just purely sort of cultural norms. And so I collected a bunch of them. These are the sort of ones that I could think of, and I tried to group them roughly into things that are sort of fundamental technical challenges of publishing software in maybe journals or in other places. And so how do you cite software is kind of an open question for journals and for publishers and for people who care about creating the kind of metadata record that surrounds the literature. Some things are just kind of weird policy quirks that some journals still have, that software citations just simply aren't allowed. They're not real. You can't cite them. It has to go in the acknowledgements or something. There's this sort of idea that maybe software isn't natively citable, like is a GitHub URL a citation? If not, what is? So this is something where there's been groups thinking about that. Perhaps more importantly, as an extension of that, imagine you have a literature that's full of citations to software. We have these things like H-indexes that get used, and people count citations and use them in kind of sometimes pretty blunt, brute force ways. So if software citations aren't being indexed, then this potentially doesn't have an immediate effect on somebody's career. And then there's kind of interesting things about the sort of peer review of software. If we think that software should be a first-class entity as a scholarly output, well, we might want to think about how do we maintain quality and what does review look like. And I know that some communities, you could argue that peer review is a pull request on GitHub, and I'm completely on board with that idea, but just is that something that we should try to be established as a norm? What does it look like for software to go through peer review? And then you can forget the software can't cite other software. That's probably just a requirements.txt. But anyway, so this is sort of some of the challenges, I think, to software becoming a first-class citizen more generally in academia. And it turns out that we're pretty lucky in astronomy. And I think these are the two main reasons that we are lucky. ADS is what I like to call a benevolent indexer. We have an ADS, for those of you who don't know, is a NASA archive. It's one of the 4, I should know exactly how many there are. Let's say there are 4, maybe there's 5. ADS is a NASA archive. It kind of does what we want it to do. I mean, you can't just go to Alberto Akamosi and ask him to build 10 new features for him, but they are responsive to the community's interests and needs, and so we can affect how ADS presents your work, represents your work to the community. So the fact, lots of communities don't have an ADS. They have to just use something like Web of Science or Scopus, other indexers where now there's under the sort of influence and control of commercial entities. So this benevolence is very important, I think. The other thing is that many of our journals and our most prestigious journals and most well-read journals are society-led and operated. That's also a big deal. These are, AAS journals kind of belong to us at some level. They're professional society that we belong to, and we can, if we don't like what they're doing, we have some chance of influencing what they do. So we're in a pretty good position as a community, and so lots of what I just talked about before really doesn't count in astronomy these days, but it's just to give you an idea how lucky we are. So I said how to get career credit for software, so I want to talk about 2 things that I think you should do, and hopefully none of this is new to most of this audience. One is make something citable, and what I mean by that is something that isn't just a GitHub URL. There's this sort of growing feeling that a URL is not an acceptable thing to cite. Indexers aren't particularly interested in it. So here's a guide you can follow, which basically shows you how to hook up a GitHub repository to Zenodo, which is an archiving service, which basically gives you, takes a snapshot of the code, gives you a DOI that comes from DataCite, and then gives you a snippet that you can put in your references. And of course, there's other places that you can make something citable. So here's a journal by Elsevier. This is Astronomy and Computing, which some of you have published in. You could write a paper here. There's a more sort of generic Elsevier publication called Software X, which is sort of a general journal for software submissions. There's also JAWS. Some of you might know this journal, Journal of Open Research Software. There is, of course, now you can put software papers into AppJ, into I think all AAS journals now. you can submit software papers to. And there's also this journal, which, full disclosure, I built and I'm the editor-in-chief of, so there's also places that are trying to take very lightweight, software-focused review with a short paper. JOS is a place to publish, and some of you in the room have done exactly that. So there's a bunch of different ways to create something citable. And then I think the next thing to think about is make it really, really easy to be cited. And so there's some conventions that you see in the community. So here's one of Dan Foreman-Mackey's packages, making it really explicit. Don't just give people a string, give them the BibTeX entry to put into their paper, I think is a really obviously good thing to do. There's also some sort of emergent ideas around these things called citation files, so a plain text file that you can put in your repository, where you basically say how you want to be cited. These are very popular in the R language. I tried to find as many as I could on public repos and GitHub, and there's tens of thousands of them at least. And actually, R uses these as the standard preferred way of writing down how the package should be cited. And then there's also people will add things like this. This is just a citation file that's with some of the software carpentry lessons. So Greg Wilson's just put a couple of snippets in here. But there's definitely some interesting ideas about sort of machine readable versions of these. So you can ask an R package what its citation is, and it will tell you. So here's a package by Hadley Wickham. And actually there's some traction. So the AstroML package by Jake van der Plas implements this. So I think there's some conventions, certainly very strong conventions in R, and I think it would be interesting for more packages in this community to kind of follow this convention. And then you can think about building tooling up around how to help somebody put the right set of citations in their publications. So I said things have changed over the last few years. This is now about 2.5 years old, this statement on software. The AAS has basically said you can publish any kind of software paper you want in our journals. You do not have to include research results. There's no minimum length. And this is, I think, a huge deal for this community, and I think we're in a pretty strong position because of this. So I wanted to recap. So if you haven't been listening so far in my talk, this is exactly what I think you should do today, and I think this talk would change probably in the next year, but tell me exactly what to do. Publish your software somewhere, put a code, put a license on it, that's important. Make an archive, make something citable. Encourage people to cite you by making it super easy for them. Maybe write a short paper, research note, or publish in JOS, or if you really want to get all the emoji success, then you should write a bigger paper that people take more seriously, or something. So that's where I was going to end my talk, and I realized that actually I want to give another talk, and I know I've only got 2 minutes, so I'm going to show 3 more slides, which I think is a sort of a is what I also think we should do as this community, which is not how to get credit, how to give credit. And so this is very much a work in progress, so this is me starting my second talk of the morning. And I think fundamentally the question is, think about where you have power and influence in the research cycle as an academic. And I decided to do this last night after 2 old fashions, and it was a bad idea. But here we go. So this is what I could come up with last night. And here are some places where you have power and influence as an individual. So in your research group, when you're thinking about, should we publish our software? Yes, let's do that. Look, I've done it. It's on GitHub. I put a license on it. You can, individual actions you can follow. When you're reviewing, whether you're reviewing a paper, pretty powerful as a paper doing in the peer review process, this paper seems to be missing the following 5 citations to software packages. Also, when you're reviewing grants, data management plans, there's lots of opportunities to have influence at that point. If you're in the privileged position of searching for somebody to come and work in your department or institution, starting to say, well, I know we're just looking at papers, but did you realize this person wrote all these packages, and look, and we should talk about that as well. Also, an extension of that, tenure review committees, if you get to sit there. And I think also just when influencing policy, so think about where these changes at AAS level happened. This happened because a bunch of people decided to get interested in that, and at the AAS meeting started to talk about it and get AAS to modify their policy. So this is just somebody paying attention to the problem, doing the sort of committee work. And so I think there's a bunch of opportunities where you have some say over sort of how we can kind of change the norms and the cultural norms of our field. And so I will stop there. Thank you. I think I got 5 minutes, but I don't know. Yep. Oh, sorry. Oh, yep.
First.
Oh, whoever wants to go first.
Thanks very much. I just had a question as to, have you thought or given much thought to dependencies? So say I use SunPy, that depends on AstroPy.
Yeah.
Do I need to cite all the dependencies? Because the work in AstroPy may have been very important in my research, but I accessed it through another. Or AstroPy is a dependency of the package, but the specific routines I used didn't use that. So I was wondering if you've given any thought to that.
Yeah, a lot. So I've written a paper or two with a guy called Dan Katz on a thing called transitive credit, which is that, the credit actually is a transitive property because of the dependency. So, should I cite the Linux kernel? People always ask me. I'm like, I don't know. I mean, my best guess is if you think there's an individual who would get career benefit from that citation, you should probably cite it. That's my best kind of heuristic right now. I think it's complex. Fundamentally, we don't have a good way of capturing that. So I think, I would definitely cite AstroPy. I'd probably go one level deeper and cite NumPy and SciPy, but I don't think I'd go further than that. Probably. I don't know. It's not clear really, and I think fundamentally it's a limitation of the way that we index things. So yeah, there's a thing called transitive credit. There's a paper or two on the archive about it. It's a research question, and ideally, I would love to see something like ADS take that on, because I think that if somebody is using some high-level package, like SunPy maybe, then actually those citations should filter down. There should be some measurable effect to the rank or importance of the packages that it's dependent upon. And I think, like libraries.io and Dependencies try to do this just by looking at requirements, just looking at how package dependencies on GitHub, and they basically applied like the PageRank algorithm to dependency files, and you can see the really heavily used software that's a dependency of lots of other stuff.
Thank you very much. So when it comes to publishing a paper on your software, because the journals you mentioned were peer-reviewed, what's the peer review process for a code? Because if it's very niche, then the person who's peer reviewing your article might not understand necessarily the fundamental science that the code is for. So how does that work?
So I can speak to how we do it with JOS, which is we generally try and make sure that our reviewer has both domain expertise and technical, and that usually means that we have more than one reviewer for exactly this. We ask people to do a technical review, but then there's also sort of sometimes like an algorithm review, like is this giving the right kind of answers? I mean, to some level of confidence. I mean, it's as far as there's only so far you can go in a review. AAS journals, I do not know. I don't think they look at the software typically, which is one thing I would. So that you submit a software paper and there is no review of the software. And that's something that I'm actually working with them on right now. I think you should be able to say, I would like a review of this software as well. But they're not set up to do that. They don't have a reviewer pool of people who said they'd like to review software. That's something we do have with JOS. We've got a few hundred people who said, I would like to review software.
Yeah, because the follow-up question is, what's the level of software that gives it access to a journal? Does it need to be fully tested? Does it need to have unit tests for everything? Does it need to be very modular? Does it need to be like as good as an AstroPy or an affiliated AstroPy package?
Yep.
But if you say that they don't review the software, then can't.
I mean, you can publish a paper in AppJ that's closed source software that you haven't shared with the reviewer, right? So, I would argue that's better than nothing. And now, so the challenge is to advance what is considered acceptable. And yeah. So.
In my code review group, we just had someone submit something to Joss live in code review. And so that was kind of cool because he was like, and these are all of the requirements. And I think that you have done a way of building of saying there should be testing, there should be documentation.
Right.
You know, your documentation should work. That, you know, there should, so I think you are thinking about these basic requirements, and
sure.
I think that's a great place to start.
Yeah, I mean, so we're not reviewing we're reviewing the software primarily. I mean, the papers are very, very short, and deliberately so. Yeah.
Let's thank Arfon. Sorry for.
Thanks.